steps we should get an answer for a given particular definite integral. So we begin with the integral. First example, it is an integration 0 to pi by 2 sine raised to 3 by 2x divided by sine raised to 3 by 2x plus cos raised to 3 by 2x dx. Then this is a standard first example. It is standard 0 to pi by 2 sine raised to 3 by 2x. So divided by it is an integration 0 to pi by 2 3 by 2x sine raised to, then this is a standard nx sine raised to the power nx plus cos raised to nx dx. So this is given by the value pi divided by 4. Here the value of n is 3 by 2. The answer is independent of n. Therefore, using this property of integration and a formula, so right answer is pi by 4. That is option B is a right answer. We'll move to a next example. It is an integration pi by 4 to pi by 2 cot x dx. So integration we write it. So pi by 4 to pi by 2. So cot x, it is an integration. Yes, cot x, it is an integration for function. So we integrate this one. Cot x integration is log of, it is a sin x, and limit is from pi by 4 to pi by 2. Now we'll take the value of x equal to upper limit, that is log as is sin pi by 2. Sin pi by 2 is sin 90 degree, it is a 1 minus the value of x equal to lower limit, that is log sin pi by 4, that is 1 by root 2. So further log 1 value, it is a 0. Then further we write 0. This minus log, we can write this as root 2 raised to minus 1. Just we have taken a inverse. So log, using a property of a function logarithm, so we can write this as a log root 2 minus, we have to take it that side, so we get a log root 2. Therefore log root 2, that is option B is a right answer. We'll move to our next example. Integration 0 to 1 by 2 dx divided by under the square root of 1 minus x square. So directly we integrate. So it is a standard function 1 divided by root of 1 minus x square. Integration is, it is a sine inverse x, limit is from 0 to 1 by 2. Now we take the value of x equal to upper limit 1 by 2. So 1 by 2, it is a sine, we'll get sine inverse 1 by 2, right, minus it is a sine inverse 0. So we get a sine inverse of 1 by 2, it is a pi by 6, that is 30 degree minus 0. So we get the answer as a pi by 6. Therefore option B is a right answer. So further we'll move to our next example. It is an integration 0 to pi by 2 dx divided by a square cos square x plus b square sin square x. It is a standard function. So once again we write integration 0 to pi by 2 dx divided by under this whole divided by a square cos square x plus b square sin square x. So it is a standard function. Integration of this is, it is a pi divided by 2ab, pi divided by 2ab. Therefore here it is a same function. Therefore option D, pi divided by 2ab is a right answer. Okay, further example number 5, integration from 0 to pi by 2 dx divided by 1 plus tan x. So we need to simplify. So for your understanding, I write a few steps. So afterwards you can use a shortcut of this. So it is a dx as it is I write. Tan can be written as sine by cos. So it is sine x divided by cos x. And 1 as it is, here it is, nothing is there means 1. So further limit is from 0 to pi by 2. So LCM is a cos x plus sin x divided by cos x. Transport it in a numerator. So we get cos x divided by cos x plus sin x into dx, which is similar to a first example. Here the value of a n is cos raised to 1x divided by cos raised to 1x plus sin raised to 1x. So it is, we can write answer is, it is a pi by 4 here. It is a standard function. Therefore option B is a right answer. Okay, further example number 6, integration from 0 to a under the square root of a square minus x square into dx equal to. This is also a standard function. So integration 0 to a under the square root of a square minus x square into dx it is. So this is a standard function. It is a pi a square divided by 4. Pi a square divided by 4. Therefore option D, pi a square by 4 is a right answer. Okay. We move to our next example. It is integration 0 to pi by 2 log of a tan x into dx. So using the property of a definite integration, we will evaluate this. So we write this as a I equal to 0 to pi by 2. It is log of tan x into dx. So further we call it as a equation 1. We use the property of a definite integration, that is a I equal to, see, upper and lower limit as it is we write log of tan. Now x we will replace it by upper limit plus lower limit minus x here, that is pi by 2 plus 0 and minus x, right. So further I equal to 0 to pi by 2 log of tan pi by 2 minus x is, it is a cot x into dx. We call it as a equation 2. Now we will add equation 1 and 2. So I plus I, we get a 2i equal to, see, limits are common. So 0 to pi by 2, we get a log of, it is a tan x plus log of cot x. So further we need to simplify this one. It is integration from 0 to pi by 2 log of, it is a log a plus log b is log a into b, that is tan x into cot x. So these are tan and cot reciprocal of one another. They get cancels. We get a 1. Log 1 value is a 0. Therefore whatever integration comes is multiplied by a 0. Therefore we get answer as a 0. So 2i equal to 0. So I equal to 0. Therefore option A, 0 is a right answer. Further we'll move to a example number 8. It is integration 0 to infinity x square dx divided by x square plus a square, x square plus b square, x square plus c square. So equal to pi divided by 2 a excuse me, a plus b into b plus c it is. So integration of this function we have to find out. So it is integration 0 to infinity. So here numerator x square here, so here it is x square missing, so we write this first as it is dx, it is x square plus 4 can be written as 2 square, right, and x square plus 9 can be written as 3 square. So further one more term we require, one more factor we require, so here we multiply by x square, to balance it we divide by x square, we want plus c square, I take it as 0 square here. Therefore comparing this we get a equal to 2, b equal to 3, c equal to 0. So we get this as pi divided by 2 times a plus b, that is a 5, b plus c, it is a 3, c plus a, it is a 2. Yes, yes, if you simplify this, yes, we get a pi divided by 60. Therefore option A, pi divided by 60, is a right answer. Yes, okay, right. We'll move to a next example. Integration 0 to pi dx divided by a plus b cos x. So given integral is, it is integration 0 to pi dx divided by cos x. So it is also one of a standard formula. Its integration is, it is a 2 divided by under the square root of a square minus b square is multiplied by tan inverse root of a minus b divided by a plus b tan x by 2, and limit is from 0 to pi. Okay, further we have to take the value of x equal to upper limit minus the value of x equal to lower limit. Yes, so we take a value of x equal to upper limit, so we get 2 divided by root of a square minus b square into pi by 2 it is, minus 0 we are going to get it. So further 2 get cancels. If you simplify this, we get a pi divided by under the square root of, it is a square minus b square. Therefore option A, pi divided by under the square root of a square minus b square, is a right answer. Further we will move to a example number 10. It is a integration 0 to 1 tan inverse x dx. So you know, all of you, log x integration we can't find it using our regular method, so we have to use the method of, yes, it is a integration by parts. So we have to use integration by the parts. So it is a integration 0 to 1 tan inverse x, we take it as a first function, another one, that is a 1 as a second function. So now we have to use integration by the parts. It is first function as it is, integration of a second function, one integration is, it is a x, and minus integral sign. Yes, first function integration, that is a x. Yes, one integration is x. Now tan inverse x differentiation we have to find, 1 divided by 1 plus x square and into dx we have to write it. Okay, further the value of x we take it as a 1, tan inverse 1, tan of a what value is a 1, it is a pi by 4, and minus 0 we are going to get it, so we will leave that. So further I write integration 0 to 1. So x into 1, x divided by 1 plus x square into dx. So here denominator differentiation, 1 is 0, x square is 2x, 2 is missing, so to balance it I multiply by 2 and I divide by 2. So further we can write this as pi by 4 minus 1 by 2. It is a log of a denominator 1 plus x square. Limit is from 0 to 1. So further we take the value of x equal to upper limit. Now pi by 4 as it is, upper limit we get 1 by 2 log 1 plus 1 square, that is we get a 2. Further minus lower limit log 1 plus 0, that is a log 1. Log 1 is 0, therefore we get a solution pi by 4 minus 1 by 2 log 2. Therefore we can see here it is a clearly option C is a right answer. So further next example, it is integration 0 to 1 under the square root of 1 minus x divided by 1 plus x. So we'll take a integral root of 1 minus x divided by 1 plus x. To simplify it is, we will do the rationalization. Denominator is 1 plus x. Rationalizing we get 1 minus x divided by 1 minus x. So further it is a integration 0 to 1. 1 minus x into 1 minus x, 1 minus x whole square. Square and square root get cancels. We get a numerator as 1 minus x. And denominator we get under the square root of a plus b into a minus b, 1 minus x square it is. So further we split this one integral as a two integral, that is it is a integration 0 to 1. So first term divided by denominator, so that is 1 divided by under the square root of 1 minus x square. Further minus it is second term divided by denominator, that is 1 minus x square. So it is a standard function. This is a standard one. Here it is denominator differentiation. So minus 1 differentiation is 0, minus here it is minus is there, x square 2x. So here it is we have multiplied by 2. To balance it we have divided it by 2 into dx. So further, so integration of 1 divided by 1 minus x square is, it is a sine inverse x, it is sine inverse x minus, and here we get a plus here, right? So 1 by 2 as it is, because here it is a minus we have to take, and to balance it we have to divide by minus. So 2 into it is 2 root of f of x, integration 1 minus x square. So after simplifying, yes, so now limit is from 0 to 1. After simplifying, now we have to take the value of x equal to upper limit minus the value of x equal to lower limit. So simplification gives us pi by 2 minus 1 here. Therefore option B is a right answer. We will move to example number 12. Which one of the following is not correct? Okay, so we have to write answer which is not correct. Okay, so option A, it is 0 to a f of x dx equal to 0 to a f of upper limit plus lower limit minus x. This is a right option. Okay, here in a second option, minus a to a f of x dx, it is a 2 times 0 to a f of x dx it is. So this is a function, it is not true for all the function. If it is a even, it will satisfy this relation. If it is a odd, does not satisfy. Therefore B is a wrong answer. And C, it is using a property of a integration, any function we can apply it. And D also, it can be applied to any question here. So here B, it is applied only for a even function. Therefore option B is not a correct option. Therefore we can say B is a answer here. B is the answer. Yes, B is the answer. So we'll move to a next example. It is a example number 13. It is integration 0 to pi by 4 tan square x dx. So we use a trigonometric identity, that is 1 plus tan square x equal to sec square x. So I can write integration 0 to pi by 4. I write a solution for a tan square. It is a sec square x minus 1 times dx it is. So further we will find the integration of this sec square x. Integration is tan x and minus as it is x. One integration is x. Limit is from, it is a 0 to pi by 4. So further the value of x will take a upper limit. So it is tan pi by 4. 1 minus x equal to pi by 4 minus lower limit it is. So it is a minus of 0 minus 0. So it is a 1 minus pi by 4. Therefore option A, 1 minus pi by 4 is a right answer. Okay, we will move to our next example. Integration from 0 to 2 mod of 1 minus x dx. So mod means we have two values. Modulus of a function, we have two values, when it is a positive, when it is a negative. Therefore here the given interval is 0 to 2. So we can clearly observe that mod of 1 minus x, it is positive if x greater than 0, less than equal to 1, and it is minus 1 minus x if it is greater than 1 and less than 2 it is. Okay, so we will split this as a two integral, that is first x value is 0 to 1, it is plus 1 minus x it is, and further plus another one is 1 to 2, it is limit is from, it is minus 1 minus x it is. So integrating we get x minus x square by 2, okay, plus integration of this plus into minus, minus we get it, so I write directly minus excuse me, one integration is x minus x square by 2. Here it is a limit 0 to 1 and here it is a new limit, it is a 1 to 2. Now we will put the value of x equal to upper limit, we get a 1 minus 1 by 2, minus lower limit we get a 0, further minus value of x equal to upper limit 2 minus 2 we get it, minus lower limit 1 minus 1 by 2 it is. So further plus 2 minus 2 get cancels, so we get answer as it is a 2 minus 1 or else it is a 1. Therefore option B is a right answer. B is a right answer. So further we will move to a next example. It is integration 0 to pi by 2 sin x minus cos x whole divided by 1 plus sin x into cos x dx. So the given function we can take it as 0 to pi by 2, yes, pi by 2 f of x. So this function we have taken it as a f of x. Further we will check whether it is an even function. For that condition is f of pi by 2 minus x here. So wherever x we have to replace it by pi by 2 minus x. So it is sin pi by 2 minus x cos pi by 2 minus x whole divided by 1 plus sin pi by 2 minus x into cos pi by 2 minus x. So further, sin pi by 2 minus x, using a allied angles of formula, it is a cos x, and here it is minus, it is a sin x, divided by 1 plus, using a allied angles, it is a cos x, and here it is a sin x. So look at a function, here it is a plus cos x and here it is minus cos x. Yes, minus cos x. So we take a minus common outside, minus, it is a sin x minus a cos x, whole divided by, it is a 1 plus sin x into cos x. So further, it is a minus, it is a, we get this function as, yes, it is a f of x. So we observe that f of pi by 2 minus x as minus f of x. So it is a odd function. It is a odd function. So integration of the given 0 to pi by 2, 0 to pi by 2 f of x into dx. Since it is a odd function, the value of this integral is 0. Therefore, option B is a right answer. Option B is a right answer. So in this class we have studied definite integration using some of standard properties. Next class the same concept will study. So once again, thank you very much. Good afternoon.